Hello everyone, so for today's video we're gonna talk about rational function. So what is rational function? It is a function that can be expressed as a quotient of two polynomials where the denominator is not equals to 0. It is a form of qx equals px over qx where p and q are polynomials and qx is not equals to 0. So that is a rational function. So we have domain of rational function. It is a set of values of x for which the denominator qx is not 0. So how to find the domain of a rational function? So we have here example number 1. Find the domain of fx equals x squared minus 3x minus 2 over x squared minus 4. So the first thing to find the domain is set the denominator equals to 0. So x squared minus 4 equals to 0. And then factor out. So x plus 2 and x minus 2. And then set the factored number equals to 0. So x plus 2 equals to 0. Then x minus 2 equals to 0. And then transpose. X equals negative 2. X equals positive 2. Positive 2 become negative 2 because we transpose it and it passes the equal sign, and same what happened here. So our answer here is thus the domain includes all x not equal to 2 or negative 2. So that is our answer. So that is how you find the domain of your rational function. Next, example number 2. Find the domain of fx equals x plus 3 over x squared plus 2. So the answer here is all real numbers, because the domain of this function is all values of x except where x squared plus 2 equals 0. However, x squared plus 2 equals to 0, x squared would need equal to 2. X squared would need equal to negative 2. So if this is the form, so we can factor this out. So x plus 2 and then x minus 2. So f positive x squared plus 2, so if you factor it out, so it can't be factored. So x plus 2 and then x plus 2. 2 times 2, 4. Or x minus 2, x minus 2. Negative 2 times negative 2, positive 4. So no. So the answer is no. So therefore, the answer here is all real numbers. So we called asymptote, a line such that the distance between the curve and the line approaches 0 as they tend to infinity. So there are three kinds of asymptote: the vertical, horizontal, and oblique asymptote. Vertical is the y, horizontal is the x. So first, vertical asymptote. Vertical lines near which the function grows without bound. So how to find the value of vertical asymptote? So we have here an example. So x squared over x squared minus 8x plus 12. So the first thing to find to solve here is set the denominator equals to 0. So the solution here is similar to how to find the domain. So x squared minus 8x plus 12 equals to 0, and then factor out. So the factor of this is negative 2 and negative 6. Negative 2 and negative 6. And then set the factor equals to 0. So x equals 2 and then x equals to 6. So thus the vertical asymptote of given function is x equals 2 and x equals 6. This is our answer, the vertical asymptote. So next we have the horizontal. An imaginary horizontal line or a graph that shows the general direction of where a function might be headed. So there are three possible cases of existence on horizontal asymptote. The n is greater than m, the n is less than m, and m equals m. So first, we have n greater than m. So for example of this is 5x squared plus 3 over 15x plus 5. So 5x squared is greater than 15x. So number 2, n is less than m. So 15x plus 5 over 5x squared plus 3. So 15x is less than 5x squared. So in order to find this, you will base the exponent. So here in number 2, if this is the possible case in the given of your assignment, so the answer here is, the solution here is similar to finding the domain and the vertical asymptote. And then if here number 1, if this is the case scenario in your problem, so the answer here is no horizontal asymptote. And then last number 3 is when the n is equals to m, so same exponent. Example here. Find the horizontal asymptote of 8x squared minus 3x plus 4, 2x squared minus 22. So 8x squared minus 3x plus 4 over 2x squared minus 22. As you can see here, they have the same value, the x squared and then the x squared. So the formula you're going to use is y equals nm. So 8 over 2. 8 divided by 2, 4. So therefore, our horizontal asymptote is y equals 4. So that is how you solve a horizontal asymptote. So again, in horizontal asymptote, there are three possible cases. The n is greater than m. So here, no horizontal asymptote. The n is less than m. So find the x. And then n is equals to m. So y equals n over m. So next, the last, oblique asymptote. So in oblique asymptote happens when the polynomial in the numerator is of higher degree than polynomial in the denominator. So in order to find the oblique asymptote is we have to use the syntactic division. So here is the solution. So given is 3x squared plus 2. divided by x minus 1. So we're going to use the numerator. And then we're going to follow the ax squared plus bx plus c equals to 0. The value of our ax squared is negative 3. The value of our bx is 0 because it doesn't indicate here in the given. And then our c is 2. Then synthetic division. The lowest common same possible number here is 1. And then bring down 3. Negative 3 times 1 is negative 3. 0 plus negative 3 is equals to negative 3. Negative 3 times 1, negative 3. 2 plus negative 3 is 1. Negative 1. So, therefore, negative 3x and 3 and then the remainder 1. So, negative y equals negative 3x minus 3 is our answer here. So, that is how you find the oblique asymptote, only using the simple synthetic division. So now, a rational equation. An equation containing at least one fraction whose numerator and denominator are polynomials. This fraction may be on one or both sides of the equation. A common way to solve these equations is to reduce the fractions to a common denominator and then solve the equality of the numerator. For example, 2 minus x over 3 plus x equals 1/2. So, you have to do the cross multiply. So, 1 times 3x. So, 3x. 3 plus x. Sorry. 3 plus x. And then 2 times 2 minus x. So, 4 minus 2x. And then transpose the 2x. So here the x side. And then here the numbers that has no variables. So 4 minus 3. So and then add x plus 2x. You have imaginary 1 here. So 3x equals to positive 1. Divide both sides by 3. X remain. So equals to 1/3. So our rational equation here is x equals 1/3. So that's the end of rational function. I hope you learned something, and if you have any questions and clarification, please comment below.